Hi, this is Ranjit Kumar. I'm going to present a topic about increasing productivity by reducing cycle time in assembly line using lean techniques. So here comes a vision. So my vision of the project is to analyze the better customer requirements in the production line, and this is where the lean production techniques are applied. So the next aim is to fulfill the customer requirements when the actual production is less. So and next is the time study, line balancing, and maintaining the worker balance are defined. So coming to lean production techniques. So lean production techniques is a set of tools that aims for the continuous elimination of the waste in the production process. So the main benefits of these are lower production cost and a shorter production lead times. So more precisely, some of the goals include defects and waste, cycle times, inventory levels, laboratory production, utilization of equipment, and flexibility. As all these we terms came to know that the cycle times are different, where cycle time is the time taken to complete an entire production in the assembly line. So coming into the value stream mapping. So value stream mapping is a flow chart is to use to illustrate, analyze, and improve the steps required to deliver product or service. So value stream mapping is a key lean tool methodology and is the process and steps to identify and deliver to the customer. So value stream actually is especially useful to find and eliminate the waste. Items are mapped as a value added or non-value added from the customer standpoint with the purpose of rooting out that non-value added activities. Coming to the steps to create value stream mapping. So here these are the steps that we follow in the value stream mapping. So the first we comes is identify slice of product, and the next is second one is empower the right team. The third one is decide the problems you are solving. So after deciding the problems, we have to bound the process. So when finishing the process, we have to map the bounded process, and after that, we have to collect some data in the value stream mapping. So while after collecting the data, we have to create a timeline of the project. So then we have to access our current map, and finally we have to design and implement the future map. So all these are the steps to create a value stream mapping. So coming to the next is the value stream mapping structure. So here we can see that supplier, production control, and customers and shipment, all these process comes in the value stream mapping. So value stream mapping, first the raw materials are supplied to the production control through the shipment. Then the process done during the production are milling, welding, painting, and assembly production. Here you can see that all the four steps from the production control is milling, welding, and painting assembly. So after the products are ready, they are sent to the customers to the shipment. So these are the steps that we follow on the value stream mapping. So this is the common step. We just follow the day-to-day activities in all in the industries. So coming to this, some of the few process that we use in the lean techniques are just in time. So just in time is nothing but what is needed, when is needed, and amount needed at the proper time is just in time. So just in time production serve to reduce overall business cost, eliminating the process and excess inventory and their associated cost. So here the Toyota found that just in time system reduced the lead time on the orders by one third and reduced production cost by 50%. So coming to the next is Kaizen. Kaizen means nothing but change for better continuously. So quality in Toyota just-in-time reduction system was based on the Kaizen continuous improvement concept. So this approach is used to create trial and error experience in eliminating waste and simplifying the process. And this approach is repeated over and again continuously for looking for the problems and solution. So finally, Kaizen is for small improvements but carried out on a continuous basis and involve all the people in the organization. The third one is talk time analysis. Talk time analysis assume a product is made on a one unit at a time at a constant rate, reducing the net available work at a time. So the talk time is the amount of the time that must be elapsed between two consecutive unit completion in order to meet the demand. Coming to the next is the research question. Here, some of the research questions have done So the first data question is how to reduce the cycle time in air suspension assembly line using lean tools and techniques. The next one is how to identify the process capability for the assembly process of air suspension. The third one is how to reduce the material handling time. And finally, how to reduce the enhanced process parameters. So methodology I have used in this process is first we have to study the process. The second one is we have to identify the problems listed below. And after identification, we have to put the root cause of the problems and we have to list the problems. And the step four is we have to, after root causing the problem, we have to analyze the problem. And finally, we have to conclude and resolve the problem. These are steps carried out in the methodologies. And coming to the next, these are challenges I have been done. So the first challenges is the workers are not utilizing the time properly, and second one is excess usage of resources unnecessary in production line to stacking up buffer storage. The third one is production sequence is not carried out effectively, and the fourth one is unnecessary idle time of the machines in the production line due to the bottleneck in the process. And next is during shift change process not held for the more than an hour. And next is the loading is done by forklift, but the forklifts allocated only for the transporting raw materials in the assembly line. Hence, separate forklift is not allocated for production line. These halting production line process until the forklift arrives there at the point. So coming to the next is the regular maintenance of machine is not done accordingly, resulting in frequent machine failure handling during the production. So the last one is all the above lean production techniques were applied over the above challenges in order to improve the efficiency in the production. So these are the challenges I have faced in this process. So, and finally, I've concluded that in this manufacturing, there is always one part of the process that is the slowest and it may change as the production line apart. So they can stay in one place and continuously slow down the whole line. So identifying these bottlenecks will result in a major performance and improvements. So by identifying these bottlenecks, so we will be able to see in the results the performance and improvements. So the objectives of the paper is to demonstrate determination of buffer to increase the line efficiency in a transfer line where several workstations are linked together by a conveyor. One of the common problems of a transfer line in minor stoppages, that is a short mission adjustment, and so they are typical problems which result in a low uptime efficiency and are determinal to productivity. Thus, the buffering stock is designed to mitigate the problem. However, the knowledge is determining optimal number of buffers is not a relevant. It's not a prevent. The buffer analyzing using constant downtime distribution is employed in this paper. So these are the reference, and finally, thank you.